Hello everyone, I hope you already installed R Studio and enable R Markdown. In this lesson, you will be learning how to import different types of files. So you use TXT, CSV and XLS files in previous lectures, and you will be learning how you can import them, and after you analyze your data, how you can export them in your desktop. Then you will be using some logical operators and how you can select some parts of the data. It's more like extracting the variable information from your data set, and how you can summarize the simple summarization using some variables and using some functions in R, and how you can subset. It's more like you are reducing the data, or according to the objectives you need to select your data. So today we will be using this lecture slide. So you can open them, and at first you need to download handling data in R part 1, the RMD file, and part 2 RMD file. Also, after running all the programs in these two, I actually exported them into a Word file. That means knitted them into Word. If you are still not sure what is needing, and you need to go back to the previous lecture, and you need to take a look and then install R Studio, R Markdown, and basic calculation in R. For today's programming, you need to use these 4 files, download these 4 files. If you download several times, you will see that every time it adds 1, 2, 3, 4. So whenever you are calling them into your program, you need to also add that 1, 2, 3, 4 if you downloaded it several times. If you download it only once, then you don't need to add those 1, 2. So over here I actually explained what are the elements you are going to learn. So few items I explained. So at first we will start from data importation, but then again you will be learning how you can program and how you can use logical operators, all these in this lecture. So we need to work on this RMD file first. So let's see what we have in this slide. So we are going to work on how we can handle data in R, and then input and output. That means how you can import and then export the data in R. So in desktop version, if you are using the desktop version, then you need to keep everything in one folder, and then the RMD file and the data file, everything should be in one folder. So that means whenever you download these files, keep it in the same folder where you are keeping this RMD folder. If you are working on RStudio Online, you need to upload them just like we did before. So for depending on what type of data it is, we need to write different codes. Let's say we are going to import a CSV file, then we have to say read.csv. And let's say you are keeping your file in this folder. I'm just giving an example. If it is an Excel file, then you have to say read_Excel. If it is a text file, read.table. So that means these are the function we are going to use. So let's open this RMD file. At first, we need to go to our folder where we saved our file, and then you can just double click to open it, or you can just say right click, open with RStudio. And I kept all the data files in this folder. So that's my, let's delete it. Okay, so that's the R file I just opened in RStudio. Same thing you will be doing if you are working on RStudio Cloud. That means you need to bring in your RMD file in here. So let's say upload, what you want to upload, the RMD file. this RMD file part 1, open it. Same thing, you also need to upload all these files. So that means you need to upload them one by one. So I uploaded one by one of those 4 files. So all of them are here. So you need to click on your RMD file so that you can open it on your project. Previously I showed you how you can open a project and how you can create RMD file. Right now we just uploaded our RMD file. So if you are working on the desktop version, so you need to keep everything on a single folder. So we need to check at first where we are keeping our files. So let's run this where we would like to see where is it saved. So it says that this is saved in this folder. Then I say that in that folder how many files are there and then what are the names of those files. So if you write this function directory, it will show you the names of all files that you have in this directory, that means in this folder. To import the files, let's run them together so that we can bring in our CSV file, our txt file, and another CSV file, that means VRI data. So let's say run selected line. So you can see right now we have 3 data. So you can see how many rows, how many observation, and how many variables you have. All of them are listed in here. So let's open one of them. So you can see we have the object ID, species column, projected age, projected height, and then volume information of trees. All of them are here. So I have about 2700 observations. So if you keep your cursor on any numerical value, it says that in this column we have numerical information, and then the minimum value is 0, maximum value is 2800. Same thing you can check. So what's the number of column, and what's the minimum value, what's the maximum value. Let's run the same program on our Studio Online. So let's say what's the directory. If I run this too, it will tell me what we have in this project. So it says, it thinks that this is actually your folder. That means what you have it listed in here. And then let's say we would like to bring all this data file on this global environment so that we can use it on our R Markdown program. Now we can see all of them now moved from our folder to our R environment. That means we can directly call them within our program. So you will see that I kept this item as a comment because whenever we install any package, then if I need to work, then it creates some problem. That's why I always keep the installation packages. If we write any function for installing any package, I keep them in a comment. So right now I need to run them, so that's why I remove those hashtag, and then I say that I would like to keep my XLS file in here. Okay, let's run the program. Now it will actually install some packages, and then you will see that then it will be adding that file in here. So now we have the tree 2 where we have the XLS file. So after you load them, it's always a good idea to hide these two, otherwise you will see that it's actually creating some problem while you will be creating the Word file. Okay, if you want to export any of your data, you can export it as a txt file or you can export it as a CSV file. Either way it's fine. To export as a txt file, you need to use write.table. If you run this line, you will see that on your folder where you kept all your files, these RMD files especially, you will see that there is a mydata.txt file where this HDB that we just bring in, it's actually saved. Same thing for CSV file. You will see that there will be another file named, and then it will be saved as f1.save, and all the variable information will be separated by comma, and then this is the file we are saving, but we are saving as a different name. Then let's go to our file folder where we kept everything. So you can see we have a CSV file and we have a txt file. Those two are saved. So same thing will go if you do the installation and then library and then tree2, and if you run these 3 lines, you will see that it will be adding the XLS file. Let's see, and then it asks you whether you want to install, so you have to say yes, install. So maybe depending on your system, it will ask you different items to install. You need to install everything. So it's installing. While it's installing, let's go to where we were at, and if you want, you can also use this import option without writing the code, but I prefer writing the code rather using these menus on R. That's where I showed you how you can save as a txt and as a CSV file. Okay, so now we will be working on the VRI data. So how we can select the data, how we can select the variable information, that's what I mentioned here. So I said that we will be using some function. So after we bring in the data, we have to we sometimes check what's the dimension, that means how many rows, how many columns we have in the data. So you can see we can also write what's the head. That head means this function, it will tell us in the VRI data how the first few observation looks like. So when we are going to print the all the columns but first few rows. So let's go back to our program, and we already bring in our VRI data. It's in here on this side. So we are going to attach the VRI data so that we don't need to remember all the variable names. We don't need to use the variable VRI data all the time. So let's say we attach the data. After we attach the data, then you will see that it says that it's masking. It might sometimes it gives you some messages. So we actually remembered all the variable names, the object ID, species CD, so we can directly call them. Otherwise we have to use a $sign. So let's say we want to summarize the data. Let's say summarize, and then if you just want to see what you actually summarized, so it shows that for each of the variable, what's the minimum, maximum, and then all the quartiles. Also the for this qualitative information, that means species, it says that there are about 60 observations where we don't have any information of species, and then for each type of species how many observations are there. So it gives me a list. Then as we said, what's the dimension of VRI data? We already know we have 2700 observation, 5 variables. So it says that yes, it's that many rows, that many columns. Also for how many we would like to see, let's say we want to see first few, so it shows that first 6 observations, and then all the variable are shown here. If you want to see the last few observations, then you have to say tail of that data. So that means within bracket we are going to write down the name of the data. Same thing you can just go in your RStudio Cloud when everything ran, and then you can see we are going to write those two tables. It will be added in here. If you need to use it, you need to bring it in here. Otherwise, if you need to download, you can just select and then download. I showed you before. Same thing, we can attach, and we can see the first view and last view. If you are working on cloud-based, you can see we have all our printout. So on the VRI data, if you are interested to see a selected number of observation, let's say row number 10, 11, 12, 13, so you can say I added this, so a semicolon, added this colon. So I actually explain them in here. Whenever you are using it, let's say you are trying to identify few, then you will see that we are using this column. And then if you want to identify not the adjacent rows but the few rows here and there, let's say 10, 20 and 23 number of rows, then you need to name them, and you have to use this concatenate. That means you have to give a list of those observations. And if you want to know the names, that means variable names of VRI data, you have to write these function names and then write down the name of the data. Okay, so let's see how we can select row number 10 to 13 and then print out directly. So let's run this. So you will see that 10, 11, 12, 13 is printed here. So if you want to print out something else, let's say VRI, see, it's actually showing me the data and then this bracket. Then you can say, no, I want to see what's in the row number 100 up to, let's say 110, and then add a comma. And then if you want to select some of those columns, let's say last two columns, then you have to say column number 4 and 5. So let's say column number 4 to 5. I would like to print them, not all the columns. So if you leave it blank, it thinks that you want to print all the columns. If you mention the columns, then it will print only those columns. So you can see it's printing only those two columns with the observation 100 to 109. And then if you go to the next, you will see 110 is here because it couldn't adjust all those just in one window. So okay, and you can cross the output. So let's say what's the name of those variable. So that means you can just use this names function and name the data names. So I say that, okay, how about VRI data? So it says that, you know what, for the VRI data we have these variable names. So let's say I would like to know the names of other variables, other data sets. So let's say tree data 1. Tree data 1, you can see these are the variable we have. So let's say tree. So it's giving me tree 1. Let's say tree 1. Yes, so it's giving me within inverted commas what are the names of variables. So if you want to create, so I showed you in here, if you want to create the sequence, you can create the sequence, and then if you need to print out, then you have to select and then print in here 1 to 5. So using this column, you can say what's the sequence. If you need to find some statistics, let's say what's the average of those x values 1 to 5, so you can say mean of those x. That means it's giving you the average value of those numbers. So let's say you want to find the projected age 1 in VRI data, so you can directly call them. Since we already attached the variable by using the attach. Let's say attach. So what you want to attach, so let's say VRI data, then you can attach it. We already did it before, so we don't need to. If we never attached it, we have to say mean of the VRI data. Within the VRI data, we want to access to all the variables. So you can see it will give you a list if you add a $sign. So let's say projected age 1, then we can find the mean of projected age 1. Since we attach the variables using the attach VRI data before, so we don't need to use the $sign. We can directly use it. So you can see it's giving me the information. So let's say I would like to print out what type of data is the species CD1 variable in VRI data. So it says that it's a factor because we have categorical information in that variable. So I ask for other two. So it says that first one is integer and second one is numeric, because in heights we have decimals, but in age variable we have all of them are whole number. That means we don't have any decimals, or we actually don't have any negative numbers. So if you want to summarize again, you can summarize the data, and if you can go back to your cloud-based, then you can run everything. So you can see we run everything, and if you are done running the programs, you need to hide this installation before you create the Word file on the cloud and save it. Say need to Word. You will see that the Word file will be listed in here. Some errors are there. I need to fix that. It says that XLS couldn't found, so you need to hide that line as well where we added that XLS. Okay, then you will see that there is no problem. So let's see, if you again, then it says that would you like to download, say yes, download the file. That means the file is downloaded and the file will be added in here as well. Okay, so over here we are done installing, and then done with the programs with the part 1. So we need to hide those lines. So you can see we hid those lines before, and then save it and need to Word. So that will actually save a Word file. So again need to hide that line because it couldn't find. So we need to hide that part. Then you will see there shouldn't be any problem. Okay, so on your folder you will see that the data handling part 1 is saved. Okay, now we need to work on the second one. So the second one I gave you is the RMD file, and I also gave you the output. So I uploaded the docx for the part 1, part 2, and then RMD file for part 2. So let's open them, and then let's see what we have in there. So basically we will start working on the logical operator. So let's go in there. Okay, so now we are going to upload the part 2 file. So you can see I have the RMD file, so I'm uploading in here. Also I opened it on my desktop. So in here what we are basically interested is to work on the logical operators. So for the logical operators, let's go to our slide. So you can see that we are basically using the logical operator that we used to use in Excel. So you can see if we want to use less than or equal, and greater than or equal, or if it is equal, that means we have to use the double equal sign. If it is not equal, then you have to use this symbol, and then not x, that means not that variable, then you have to say not x. if you want to use the two, if you have two variables or two data set, or let's say we want to add logical operators for or that you used before, then we have to use this symbol. And if it is and, then you have to use this and symbol. So let's go to the R Markdown. So over here you will see that in the part 2 I added some examples. So let's create a variable y where we have some categorical information. So you can see y has categorical variable information. So observations are A, B, C, and D, E, F. So I say that what's the length of this variable. So it says the length is 3. That means 3 observations are there. So I said n character. So that means what are those what are the levels, that means how many characters are there. So it says that there are 3. And then I said where do we have A. So that means in the variable y whether we have A in there or not. So it says that it goes to the data. It says that okay, it tries to match. So it says that first one is true, the third and fourth one is false and false because those are not A. Same thing I ask, are these B? So it says that none of them are B because it cannot match. So I added another variable where I added 4 numerical values, and then I say that is x is actually more than 2 or not. So it says that yes, first 2 are more than 2, last 2 are false because those are not. Then I say that are there any value where we have only 2. So it says that yes, only last one is true because it's 2. So that's how we can use these logical operators. So I say that x not equal to less than 3. Then it goes everywhere and it says a yes or no. And you can see which x is actually more than 2. So it says that first 2, 1 and 2 are actually more than 2. It's not like true and false. So we already brought in previously VRI data. So I'm bringing in the VRI data again. And then you can see I brought the VRI data. So if you are not keeping the file on the same location, then you have to use the exact location of that data. But if you kept it on the same folder where you have this RMD file, then you don't need to. Then let's attach the VRI data. After attachment, you will see that these red colors are there. That means it's actually went inside the data and remembered all the variable names. So I say that what's the class of species variable. So it says that it's a factor. Then I say the how about give me a summary of that categorical variable. So it says that 59 of them has no species information, but others have species information. That means YC species we have that many observations. That means previously you worked on how we can calculate the frequency. That's what this table is telling me. So I say that how many levels we have. So it will tell me that in this species CD variable we have missing value, we have these levels. That means the name of those species. Then I say that how about create a factor and the variable information is 1010, and then I say that these are actually factors and these factors have levels 0 and 1. So you can see I only added 0 and 1, but then again I say that label them as the names. So I gave 2 names, boy and girl. So let's see eventually what we get. So if I print this variable that I just created, so it says that it's using the 0 and 1, but then again it converted 0 to boy and then converted 1 to girl. So there you can see 1 is for girl and then 0 is for boys because I how we are going to order them. So I said, how about the class of this variable? Since we are using these boy and girl, so it says a factor. What's the mode? That means how the data is entered. So it says that data is entered as a numeric variable, but then again it converted to a qualitative information. Okay, so let's see what we are doing on the cloud. Same thing. You will see that you need to bring in your R Markdown 2. So click on it, it will be added in here, and then you can run this program. So you can see what we did, and then it does the same thing on our cloud-based. Then you can just need to word and then save the word here. Also save the word in your folder, and whenever you are done working, you can just maybe select the file and then download, export them so that you can download them. So on our slide, you can see we're almost done. This is the last slide we are working on. So let's say we would like to use the subset. That means from the data we want to identify using some variable information. Let's say I would like to identify only where we have PLC species. To do that, we need to use the subset function. So in subset function, we have to write at first subset, and then what's the name of the data, and then what is the condition you want to add. So that means we are adding this condition. So species is only PLC. That means you have to use double equals. So let's see, in our VRI data we have 27 observation, but if we create another data set PLC, and you can see PLC has only 182 observation. So if I open it, I can see on my species column I have only PLC species. So if you want to see the lower and then minimum and maximum value, you can just click on it. Then you will see that we only have PLC species. And if you want to add other species, you can just write like the other species in here. So let's say we are interested to add two conditions. First condition is that it is PLC, and that means both should be satisfied. The age of the trees should be more than 100. So that means we are using this subset, and what's the data name, what's the first condition and second condition. The second condition is numerical value, that's why we are not using the inverted comma, but the first condition is PLC only. So that's why we are adding the inverted commas. So let's see, sub VRI, in this data, if we run it, sub VRI, you will see that we have PLC and the age is more than 100. So you can just click on, you can see the minimum value is 107, the maximum value is 177. We are subsetting the variable. So let's say you want to know the dimension of your subsetted data, you just subset. So it says that 180 observation and 5 variables. So let's say I am not just interested about the PLC, I also like to add other species. So I just copy pasted. So I said that create a list of other, let's say HW, and then I would like to create PLC HW stand as well. So that means these two I'm also interested, and we can use this condition as well. So let's see this first. So I just added one condition. I said that I am interested about two species. So you can see HW and PLC. So that means HW and PLC both are included. So the minimum height is 0.3, maximum height is 48. Okay, so if you are interested about adding more conditions, let's say I am also interested if age is more than 100, or let's say more than 110, that means one more conditions we are adding. If it is, we have to satisfy both, then you have to say and. If you have to satisfy either of them, then you can use or. So let's say I added or, and then this one is PLCSW, and then 110. I'm just giving another name, so you can see we are including more information. That means I added projected age, but then again I said that either of them is satisfied. That means we are including more information. So when you are done, you can just save them. If it is red color, that means you never saved it. After you added the new information, then you can say need to Word, and that Word file will be saved. Same thing for the RStudio Cloud. You can just run this program, and then you can need to Word. So try to read what I included in here, about the logical operators and the vectors we worked on, because we created the length. We try to identify the average of the values, and then some minimum maximum values, and then we also added the sequence using the colon sign, and then we imported and exported the data. So in R we also have some R built-in data, so we can also use them. So later you will see how we are using them, and how you can read data from files and write data to files. Also how you can programming concept, and how you can better write a program. The common properties, it's not that you have to do it, but there are some tips I provided you, so you can follow these. Also we worked on some logical operators, so I gave you a little bit of some description, but we are not using the loops, so I just gave you an example so that you can later on in an advanced level you can work on those. That's it for now.